Section 12.5 is going to continue with volume of some other solids. We've already discussed the surface area formulas for these two solids. Notice pyramids and cones is what we're going to talk about today. And why would they be thrown in the same section?
Well, just kind of like how when we did prisms and cylinders, they had some unique characteristics the same. These do also, because when we talk about a pyramid or a cone, we know that there's just one base and then all of the lateral surface meets up to a vertex point.
Okay, so the fact that they have some similar features, their volume formulas are going to be similar. And actually, if you look at them, they're identical. And we saw that even with surface area. Surface area formulas were very similar to each other. Again, like cylinders and prisms have some similarities. So just keep that in mind. In the end, you got a lot of formulas to remember, but look for those similarities, okay? So we have them already written here for you. I just want to make sure we're clear on it. Now, we've already seen the base area times height idea. That was involving
either a prism or a cylinder.
Now, notice they're saying take a third of that. Here's a great example of why it's a third, not exactly maybe where we got the third part, but just to give you a visual. Notice this pyramid inside of this prism has the same base area, and the vertex hits the top of this prism, so it's going to be the same height. Obviously, that pyramid doesn't have the same volume. It's obviously less. And we could actually do this, fill up that prism and then, or that pyramid, and then dump it into that prism, and it's going to take 3 of those to fill up. There's why it's a third of it. It's obviously a lot less, okay? Now, before we get too involved, I want you to notice that this is a volume of just any pyramid, okay? Doesn't have to be regular. With surface area, it had to be a regular pyramid. Just like a cone, it says just of any cone. With surface area, what kind of cone did it have to be?
It had to be a right cone.
So this volume, you kind of have some flexibility. Just like with cylinders and prisms, volume, it didn't matter, okay? So it says 1/3 base area times height, all right? So the base area depends on what kind of base it is. It could be a square base, it could be a rectangle base, it could be a triangular base, whatever. And you take it times height. Now, another way of writing that, I know I personally encourage this for some students that have struggled taking 1/3 of something, is just do base area times height, and then what would I divide it by?
Divide by 3.
It means the same thing,
right?
Okay? So something that might encourage you to write. And here, same deal. These are the same thing. Now, let's kind of go a little bit further with a cone, because what's unique about the cone's base?
The cone's base is a circle, so we've got 1/3 of the pi r squared
times the height. So you could write it as pi r squared times height divided by 3, or take 1/3 of it, right? It just kind of depends on how comfortable you are. Now, notice the other thing to notice about these volume formulas is these involve the height, whereas surface area involve the
slant height.
So the height, again, goes from the vertex to a point on the base, somewhere inside of it more than likely, and it has to be perpendicular. It doesn't have to be the center unless you have a regular pyramid, of course.
Right. But again, these don't specify, so they don't have to be regular, they don't have to be right. And that's kind of based off of that idea of Cavalier's principle that we talked about the other day.
Exactly. All right, let's apply this.
Okay, so for our first example, it says find the volume of a regular hexagonal pyramid. And right there, I'm just going to stop, because I noticed that they're asking me to find the volume, and we've got a regular pyramid.
Okay.
Which didn't even have to be regular. But what do we know about, what's the first thing I probably want to do?
Well, volume of a pyramid, I'm going to write the formula down. Now, I'm going to do base area times height divided by 3.
Okay.
Okay, you can do 1/3 base area times height. It doesn't matter. In the end, you're going to do the same thing.
All right. Well, let's keep reading. Find the volume of a regular hexagonal pyramid with a height of 5 and the sides of the base measuring 2 centimeters. All right, now, let's think for a minute. First of all, what do we know about our base?
Well, we know it's a hexagon.
Okay.
And it's regular.
It's a regular hexagon. So I'm not going to necessarily draw the whole regular hexagon. I'm just going to write, well, they're not that bad. I'll go ahead and draw it, just so we can have that visual. If you don't want to draw the whole regular hexagon, that's okay, as long as you draw at least in that little right triangle, maybe. Now, what's nice about this one, they tell us the sides of the base measure 2. So you could pull out the little right triangle if you wanted to, okay, and to help you find that base area. We do know one other piece of this, and I'm not going to even draw the whole pyramid in, but we do know that the height is 5. So I really already have the height too.
Yeah.
All right. So I just need to find the area of this base.
Well, and that's what's kind of nice. I've noticed so far volume formulas, we really only need to know 2 things, base area and height. And that goes for any of the solids we've talked about so far. So just 2 pieces where surface area, we had to find more involved. Okay?
Right.
So finding just the base area, well, I know that the area of a regular hexagon, I can just do 1/2 the apothem times the perimeter. And so let's draw in that apothem.
Okay.
And I know that it's going to bisect that side. So that's going to be 1. It's going to be a right triangle.
Mm-hmm.
Okay.
And when we try to find the central angle of a hexagon.
So that was going to end up being 30 degrees up there.
Right. And,
Well,
sorry, this is going to be 60.
Yeah.
I
was just going ahead.
60 and
We've
divided
done
by 2.
hexagons so much that I'm like, at this point in the
fact,
game.
I've noticed a lot of kids not using the half apothem perimeter anymore. And we're going to talk about that in a second too. We know this is the 30. This is our 60. Oh my gosh, I should just draw this separate because it is getting to be too tiny. But okay, so we've got our 1. This is our 30 degrees. This is our 60 degrees. And if this is the shorter leg, how do I get to the longer leg?
Radical 3.
So 1 radical 3 is just a
Just
radical 3.
3.
And we really just need the apothem because how do we find the perimeter?
Well, perimeter is going to be just taking 2 times 6.
Exactly. Which is going to give us our 12. And then we said the apothem was a radical 3.
So let's substitute that in. So base area is equal to 1/2 times the radical 3 times 12. And I'm just going to do a half of 12. And that's going to be 6 radical 3 then.
And this will be exact. That's the nice thing. We can leave this exact. And if we go ahead and go back to our original formula, because now we have base area, that volume is going to equal
6 radical 3 times my height of 5, and then divided by 3. Now, I'm going to go ahead and multiply the 6 and the 5 up top, and that gives me 30, and then I have radical 3. And then divide that by 3, I get a 10 radical 3. That would be the exact answer. And I'm noticing there's units, so we probably want to go ahead and round it. So it's about 17.
Sorry.
That's okay.
Okay, so the volume is approximately
17.32 centimeters cubed, because we're talking about cubic units.
Love it. Now, keep in mind that if you guys don't want to go through the whole hassle of the special right triangle, that hexagons, the awesome thing about a hexagon is that if I draw in that whole central angle, that really is what kind of a triangle?
That ends up being an equilateral triangle.
And they already give us a side length. So we could do the 1/4 2 squared radical 3 to get my base
One of them.
Yeah.
Not the whole base area.
You're right. Then times 6 to get the whole base area because there's 6 of those. Yeah. We could definitely do the area of one of those equilateral triangles times the 6 equilateral triangles. And I've seen a lot of kids do this, especially when they give you a side length. That's nice. Okay. Awesome.
So it says here, find the volume of the cone. Now, it doesn't say a right cone. Do we have to know it's a right cone?
We do not need to know it's
And
a right
it's
cone.
actually not. Notice how this perpendicular distance from the vertex to the base is not going to the center of the base. So we know it's an oblique cone. All right, so let's write down the formula for volume of a cone. And what is that?
Tell you what, since we did the divide by 3, let's write 1/3 area of the base times the height.
Okay, and then
Just so you guys can see both.
And you can go more specific and say, well, the base area is pi r squared. So you could
Exactly.
do that. So if we want to put that off to the side, now let's think about what we already know. They give you
They give us the radius, so we can find the base area pretty easily, and they give us the height.
so they already gave you this piece, so we can put that in there. So let's find the base area.
Okay.
So to find the area of the base, you do pi times,
3.1 squared.
okay,
Which 3.1 squared gives us a 9.61.
and then pi. Don't forget the pi.
Yeah, pi.
So
and
I'm
then-
going to put this, go ahead and substitute that in. So 1/3 times 9.61 pi times the height of 7.
Right.
Okay, let me do that since we have decimals there.
Sounds good. Now, we could leave this answer just in terms of pi and keep it more exact, but I'll tell you that we're going to get weird decimals anyway. So I'm going to go ahead and type in, we've got our 9.61 pi gives us a 30.1907, etc. So I'm going to take that times 7. And again, I could either take it divide by 3 or times 1/3. And that should give us a 70.44.
And this is
And this
inches
is
cubed
inches
again.
cubed.
All right, so again, guys, I know we wrote 1/3, but I was watching kind of Miss Hokerby type it in, and she put divided by 3. So that's where it just kind of depends on your preference. I personally just put divide by 3 because it's less buttons to push.
Oh, I usually do too. I just
Yeah.
want you guys to realize the formula
They're the
works either
same
way.
thing. Well, I know, and that's what I'm saying. This will work either way. So it's just
Yes.
what your preference is.
All right. Next one, we are going to find the radius of a cone. Okay, so a little bit different. We're not just finding the volume here.
Okay.
Find the radius of a cone, and we have the cone's volume. So right now, I'm just going to stop and think, what do we know about the formula for the volume of a cone?
Okay, so I'm going to put volume equals, let's use base area times height divided by 3.
Okay.
Let's switch gears a little bit.
Sounds good. Now, on this one, we're finding the radius, which is the radius really part of this formula?
Well, technically it is because the base area is pi r squared. So we could just go ahead instead. You guys want to do that? Let's do that. Volume equals pi r squared times height divided by 3.
Love it. That way we can actually talk more specifically about the radius.
Okay.
Okay. They give us the volume,
Okay.
so that's kind of nice. I already know that part. And they give us the height.
Huh.
So really, the
So
only
we
thing
only
I'm
have
missing.
one unknown. Okay.
Exactly. So let's
Seems easy
substitute in what we've got. 2,262 is equal to our pi r squared, and instead of just leaving it as h, I'm going to put in my 15 and divide by 3. All right, so what are you thinking?
Well, I'm thinking you could do two different things. Let me do what my initial thought was, is I see divided by 3, I can divide 15 by 3.
Yes.
So I'm going to go ahead and simplify that. So that's 2,262 equals 5 pi r squared.
Absolutely. Okay.
And then I'm going to go ahead and divide by 5 pi. Now, what are you going to remember, guys?
Hopefully we remember our parentheses.
Yep, around that 5 pi.
Yeah.
And then you're going to have r squared equals, let me type it in to double check myself here. I get about 144.0034.
So we'll just say 0, 0.
And then I'm going to
leave the decimal.
Now, after that, I'm going to take the square root because I want just the radius. I don't want r squared.
Right.
So I'm going to take the square root, do answer recall, and it ends up being about 12, which I was kind of predicting. 12 feet.
12 feet. Because this is not a surface area or a volume, so we don't need a squared or a cubic units. Perfect. Now, I love how you said that was your first, kind of your first instinct, and that's actually the first thing I saw too.
Yeah.
But I know that there's going to be students who would rather get rid of that 3. And keep in mind that you could, to clear that fraction, multiply both sides by 3. Here, the 3s are going to cancel. But I could have multiplied both sides by 3. You'd get the same thing.
And initially, guys, she said get rid of the fraction. Well, dividing 3 by 15 does get rid of the fraction. But the downfall to that is, what if that height was like 7? Well, 3 doesn't divide into 7 nicely.
Right.
So this approach that Ms. Hokerby just showed works no matter what.
Right.
Like without any nasty fractions in a sense. All right, last problem. It says find the volume of a square pyramid, okay? And I'm going to read on in just a minute, but let's just write down this. It says find the volume of a square pyramid. So I'm thinking volume of a pyramid, all right? The volume formula of a pyramid would be
1/3 of the area of the base times the height. Or area of the base times the height divided by 3.
okay. So either way. Now, it says, let's read on and hear what, because they better give us something about it. It says they give you the surface area of the square pyramid to be 1,560 square inches. Okay, so I'm going to stop for just a second. Does the surface area directly involve this here?
No, it does
No,
not.
like I don't see an S for surface area. So I'm going to go ahead and write down the surface area formula because maybe I'm going to need that, because if they give you a surface area of a pyramid, we better know it. Now, it's a square pyramid, so surface area formula works for any regular pyramid, which a square is regular.
Okay.
So what is the surface area formula?
Well, we have 1 base plus a half of the perimeter times the slant height.
Okay, so right now we're probably thinking, okay, why are we doing? I'm just writing down formulas that Well, I mean, we're finding the volume. That's what we're finding. But they give you the surface area. So somehow this has got to help us get here. Now, notice how this formula has something in common with this formula. What do they both have?
They both have the area of the base.
So we're probably going to have to find the area base somehow. Okay. And we have to know the height to find the volume. Right. Notice this is slant height. Are these the same thing?
No, they're not the same thing.
Okay, so we'll have to talk about what does this have to do with anything. All right, let's read on. It says the base's perimeter of 104. Okay, so let's think about what we do know.
We do know the perimeter.
We do know the perimeter
of the base. Which is part of the surface area formula. Mm-hmm. And they can tell us the surface area also. And we can find the area of a base. If it's a square and we know its perimeter, we could get to the area of the base.
Which if I can find the perimeter or the base area, notice the unknown is the slant height. Now, is the slant height the same again as the height?
It's not.
No, so we're going to have to talk about how is that going to help us. Okay? Because we're going to need the height, obviously.
Right.
We can find the base area, you said, but we got to find the height somehow. Slant height and height are two different things. So I want to stress, guys, if they're giving you something about the surface area, probably that means we're going to have to use it. All right? I know that a lot of students would struggle on something like this because they find the base area, and then to find the height, maybe you think it's the same as the slant height. So just be cautious with that. All right, so let's talk about the fact that it is a square pyramid. So let me draw that square. And we know the perimeter of this thing is 104. So if I know the distance around that, what could I do to find just one of the side lengths?
I could divide it by 4 because those are 4 congruent
So that
legs.
means this is 26.
Yes.
So all of these are 26. So then can I find that base area?
Absolutely.
So let's find that. So it'd be 26 squared.
Which would be 676.
All right, so now I got that. Let's put those things in. So we know the surface area is the
1,560 equals our 676 plus 1/2.
Sorry.
That's okay. Plus 1/2. The perimeter is 104. And we're going to leave it as just L for slant height.
Okay, so this really equation only helps us find the slant height. So the question that you want to be asking yourself is how does the slant height help us find initially the height? Because I'm going to go to this formula. We already have this. We really got to find this in order to find the volume. All right, so we're going to have to think, how does the slant height relate to the height? We'll talk about that in just a minute, okay?
Okay.
So let's go ahead and just manipulate this formula here. So I'm going to go ahead and simplify over here. This is, what, 52 slant height. Now,
if I subtract my 676, because they're not like terms,
yeah,
I end up with an 884. And divide by 52, we end up with 17.
Okay, so that's the slant height. Again, that's not the same as the height.
Right.
Okay, I'm going to make a note.
Remember.
Not height.
Exactly.
All right, help me remember something.
I do remember that if we drew in the actual, if we saw the pyramid itself, that the height and the slant height really formed a right triangle.
This one's a little bit easier one to draw.
Let
me draw in a square pyramid. So here's what we have. We have this piece right here. This is the slant height.
Is the height of the face, don't forget.
Of the lateral face.
The lateral face,
Okay, so when the height goes straight to the center. Or if it's a regular pyramid, which a square is, this is the height. All right?
And that makes a right triangle with the apothem. So really, if I could figure out what my apothem is, I could use the Pythagorean theorem then with the slant height that we've just found.
So let me draw this right triangle. So this is your slant height, which is your 17. Our height is our unknown. That's what we're trying to find. You're saying this is the apothem. Now, because it's a square base.
Square bases are nice because they're just half of that
side.
The
apothem is always just half of that side. Because if this is 13, this makes a 45, 45, 90. So the apothem actually is 13 as well. Okay. So we're going to set up the Pythagorean theorem. Notice and this is something I've noticed with the surface area. When you're dealing with the slant height or the height is your hypotenuse. So you're going to do 17 squared equals your 13 squared plus your height squared.
Right. Which you'd end up finding that your height squared, if you just simplify,
you're
going to end up with 120. So when I take the square root of 120, and keep in mind, you can leave it as just radical 120.
Let's just do that.
Okay. It's Sounds good.
Let's do that.
You could get a big long decimal, but no need right now.
Let's just put it in there. Now we have our base area and the height already found. Here's our base area. Here's our height. So think about the whole point of all of this was just to find the slate height, which will help us find the height. Okay, so this is a little more involved problem. This is where, you got to think about why did they give this to you. Okay, so let's put this information into our volume formula. So volume equals.
So I can say 1/3 of our 676 times a radical 120.
All right, so let's type those things in our calculator.
And I end up with 2,468.40. And this is going to be inches cubed. Cubic inches.